Hello, and welcome to our YouTube channel. Today, we're embarking on an extraordinary journey through the cosmos to explore the Sun, our very own star. From its enigmatic outer layers to the core mysteries hidden beneath its fiery surface, we're diving deep into what makes the Sun so pivotal in our solar system. Join me as we unravel these celestial secrets with the help of modern technology and some mesmerizing visuals. Let's light up our understanding of the Sun, the Sun's mystique, outer layers, and solar dynamics. The Sun, a constant beacon in our sky, is more than just a luminous body. It's a complex star with intricate layers and dynamic processes. The outermost layer, the corona, is a spectacle in itself. Captured brilliantly by the Solar Dynamics Observatory, SDO, this layer reveals the Sun's magnetic turmoil. Using 19.3 nanometer wavelength imaging, scientists peer into this ultraviolet region, uncovering structures invisible to the naked eye. This advanced observation helps us understand solar variations that affect Earth, from communication systems to climate. The Sun's fury, solar flares, and coronal holes. Diving deeper, we encounter solar flares and coronal holes, the dramatic phenomena of the Sun's atmosphere. Solar flares, massive electromagnetic explosions, result from complex magnetic interactions. Footage from August 2022 showcases these awe-inspiring events. In contrast, coronal holes are cooler, less dense regions where solar winds escape into space. These phenomena not only shape the solar atmosphere, but also influence Earth's auroras, creating breathtaking night skies. The Sun's dance, solar prominences, and coronal rain. Another layer reveals the Sun's elegant but powerful dance. Solar prominences. These are huge loops of plasma, extending far into space, often stable for months. Additionally, the Sun experiences coronal rain, where plasma cools and falls back to the surface. These phenomena, observed using ultraviolet light, highlight the Sun's dynamic nature and its influence on the surrounding solar system. Exploring the transition, Sun's lower atmosphere. As we move inward, the transition region between the corona and chromosphere shows a dramatic temperature rise from 8,000 to 500,000 Kelvin. This narrow band, imaged using 160 nanometer light, is key to understanding the Sun's energy distribution. Below lies the chromosphere, dotted with spicules, jet-like plasma structures, providing insights into magnetic and thermal processes at play. Unveiling the photosphere, the Sun's surface. Finally, the photosphere, the Sun's visible surface, is a realm of granules and sunspots. These features, observed in different light wavelengths, offer clues about the Sun's magnetic field and convection currents. The dynamic nature of the photosphere, despite its apparent stability, is crucial to understanding solar activity and its impacts on the solar system. The Sun's magnetic mystery, sunspots explained. Delving into the realm of sunspots, these darker, cooler areas on the Sun's surface are a testament to the star's complex magnetic activity. Sunspots, often as large as planets, form where magnetic fields are strongest, inhibiting convection and leading to reduced temperatures. Understanding sunspots is crucial, as they are often precursors to solar flares and coronal mass ejections, events that can significantly impact Earth's space environment. The power of solar winds, Earth's shield in action. Solar winds, streams of charged particles released from the Sun, travel across the solar system, interacting with planetary magnetic fields. On Earth, this interaction creates the magnificent auroras near the poles. These solar winds play a critical role in shaping the heliosphere, the vast bubble surrounding our solar system, and act as a shield against cosmic rays. The life cycle of the Sun, from birth to future. The Sun, like all stars, has a life cycle. Born from a nebula approximately 4.5 billion years ago, it's currently in its main sequence phase, fusing hydrogen into helium. In about 5 billion years, the Sun will enter its red giant phase, expanding and engulfing the inner planets, before eventually shrinking into a white dwarf. Understanding this life cycle helps us grasp our cosmic past and future. The Sun's heliospheric influence, beyond light and heat. The Sun's influence extends far beyond light and heat. Its heliosphere, a vast bubble created by solar winds, encompasses the entire solar system. This heliosphere protects us from interstellar radiation and cosmic rays. Studying this region helps us understand solar and interstellar interactions, crucial for long-duration space travel and understanding the broader galactic environment. The Sun's chemical composition, elements of a star. The Sun, primarily composed of hydrogen and helium, is also a source of heavier elements like oxygen, carbon, and iron. These elements, created through nuclear fusion and distributed by solar winds, are essential components of life on Earth. Understanding the Sun's chemical makeup sheds light on the processes that govern star formation and the evolution of the universe. Solar oscillations, the Sun's resonant frequencies. Solar oscillations, or helioseismology, offer insights into the Sun's internal structure. These oscillations, similar to seismic waves on Earth, help scientists study the Sun's interior layers without direct observation. Analyzing these waves reveals details about the Sun's core, including temperature, composition, and rotation, crucial for a comprehensive understanding of stellar physics. The Sun's nearest neighbors, solar system synergy. Exploring the Sun's relationship with its planetary neighbors reveals a complex synergy. Planets, moons, and other celestial bodies are constantly influenced by the Sun's gravity, light, and electromagnetic radiation. This intricate dance shapes everything from planetary orbits to climate patterns, highlighting the interconnected nature of our solar system. Solar eclipses, celestial alignment wonders. Solar eclipses, occurring when the moon passes between the Earth and the Sun, are not just stunning visual events. They offer unique scientific opportunities. Eclipses have allowed scientists to study the Sun's corona in detail, leading to discoveries about solar winds and magnetic fields. They also play a significant role in cultural and historical contexts across civilizations. The Sun's impact on Earth, climate, and beyond. The Sun's impact on Earth extends beyond daylight and warmth. Solar activity influences Earth's climate, playing a role in weather patterns, ocean currents, and even long-term climate change. Understanding this solar-terrestrial relationship is vital for predicting weather, assessing climate change, and planning future space missions. Exploring the Sun, missions, and discoveries. Numerous space missions, like NASA's Parker Solar Probe and ESA's Solar Orbiter, have been launched to study the Sun up close. These missions aim to unlock mysteries about solar winds, coronal mass ejections, and the Sun's magnetic fields. Their findings are not only significant for solar science, but also for protecting Earth's technological infrastructure from solar storms. The Sun's role in space weather, understanding solar storms. Solar storms, comprising solar flares and coronal mass ejections, represent the Sun's dramatic influence on space weather. These events can disrupt satellite communications, GPS systems, and even power grids on Earth. Understanding solar storms is crucial for developing mitigation strategies against these disruptions. Research in this field not only enhances our knowledge of solar physics, but also plays a pivotal role in protecting technological infrastructure in our increasingly connected world. The science of sunlight, spectroscopy, and solar analysis. Sunlight is a treasure trove of information. Through spectroscopy, scientists dissect the light emanating from the Sun to understand its composition and dynamics. This analysis reveals the presence of various elements and provides insights into the Sun's surface temperature and magnetic fields. Spectroscopy has become an indispensable tool in astrophysics, enabling us to decipher the secrets of our star from millions of miles away. The Sun's evolution, tracking stellar changes. The Sun, like all stars, undergoes changes over time. Studying these changes helps astronomers predict the sun's future and understand similar processes in other stars. Changes in solar brightness, surface activity, and magnetic cycles provide clues about the sun's internal mechanisms and its long-term impact on the solar system. The sun in cultural context, mythology, and science. The sun has been a central figure in human mythology and culture throughout history. From ancient solar deities to modern scientific studies, our relationship with the sun spans a spectrum of awe, reverence, and scientific curiosity. Exploring this cultural aspect offers a unique perspective on how our understanding of the sun has evolved over millennia. The future of solar exploration, next-generation missions. The future of solar exploration looks bright with upcoming missions and technologies. Next-generation telescopes and space probes aim to provide even deeper insights into the sun's properties and behaviors. These future missions promise to unlock mysteries of solar physics, enhancing our understanding of the star that sustains life on Earth. The sun's core, unveiling nuclear fusion. At the heart of the sun lies its core, a hotbed of nuclear fusion where hydrogen atoms fuse to form helium, releasing immense energy. This process is the fundamental power source of the sun, driving its luminosity and supporting life on Earth. Understanding nuclear fusion in the sun's core is crucial for replicating this process on Earth, potentially unlocking a source of clean, limitless energy. Solar cycles, the rhythm of sunspots and flares. The sun experiences an 11-year cycle, marked by varying frequencies of sunspots and solar flares. These cycles play a significant role in solar and terrestrial phenomena, influencing everything from climate patterns to satellite functionality. Studying these cycles helps scientists predict solar activity and understand the long-term behavior of our star. The sun's plasma, a state of matter in extremes. Plasma, the fourth state of matter, dominates the sun's composition. This ionized gas, with its unique properties, drives the sun's magnetic field and surface phenomena like sunspots and prominences. Plasma physics is a key area of solar research, providing insights into the fundamental processes that govern the behavior of the sun and other stars. The sun's influence on planetary atmospheres. The sun's radiation and solar winds have a profound impact on the atmospheres of planets in our solar system. From stripping away Mars' atmosphere to creating the auroras on Earth and other planets, the sun's influence is omnipresent. Understanding these interactions is crucial for comprehending planetary evolution and habitability. Solar telescopes, windows to our stars. Solar telescopes, ground-based and in space, are our windows to the sun. They enable us to observe solar phenomena in unprecedented detail, from granules on the surface to the outermost layers of the corona. Advances in telescope technology continue to provide deeper insights into the sun's structure and activities. The sun and solar energetics, powering the solar system. The sun's energy output, a staggering 384.6 yottawatts, is the primary driver of processes in our solar system. This immense energy fuels everything from the basic mechanics of planetary orbits to the complex ecological systems on Earth. Understanding solar energetics is key to grasping the balance of life and the natural phenomena that occur within our cosmic neighborhood. The sun's invisible light, beyond the visible spectrum. While the sun's visible light is crucial for life, it also emits radiation across the electromagnetic spectrum, from ultraviolet to infrared. These invisible wavelengths provide crucial information about the sun's composition, temperature, and magnetic fields. Advanced imaging techniques allow scientists to study these aspects, revealing a multifaceted view of our star. Solar wind and cosmic weather, the sun's extended influence. Solar wind, the stream of charged particles from the sun, extends its influence far beyond the visible solar system, contributing to cosmic weather. This flow of particles interacts with interstellar space, and can impact the environments of other celestial bodies, shaping conditions throughout our galactic neighborhood. The Sun's chromosphere, a layer of mysteries. Above the photosphere lies the chromosphere, a layer of the Sun teeming with mysteries. Characterized by spicules and a distinctive red glow, the chromosphere is a region of intense energy and activity. Studying this layer helps astronomers understand solar flares and the mass ejection processes that affect space weather. The Sun's future, an evolving star. The Sun, currently in its middle age, has about 5 billion years left in its main sequence phase. As it evolves, it will undergo dramatic changes, expanding into a red giant and eventually collapsing into a white dwarf. Understanding the Sun's future not only gives us insight into the life cycle of stars, but also prompts considerations for the long-term future of our planet and solar system. The Sun's radiative zone, a crucial layer for energy transfer. Beyond the core lies the Sun's radiative zone, where energy transfer occurs mainly through radiation rather than convection. This zone plays a crucial role in regulating the energy flow from the core to the outer layers. Understanding the dynamics of the radiative zone is essential for comprehending the Sun's energy distribution and the processes that fuel its luminosity. The role of gravity in the Sun's life cycle. Gravity is the fundamental force shaping the Sun's life cycle. It initiated the Sun's birth by causing the collapse of a molecular cloud and continues to govern its internal pressure and temperature balance. This delicate gravitational balance sustains nuclear fusion in the core and will eventually lead to the Sun's transformation into a red giant and later a white dwarf. The Sun's photospheric activity, sunspots, and granulation. The photosphere, the Sun's visible surface, is a hive of activity. Here, we find sunspots and granules, the convection cells that cover the Sun's surface. Granules, appearing like boiling bubbles, are essential in transferring heat from the interior to the surface. Studying these features offers insights into the Sun's magnetic field dynamics and internal convection processes. Solar observation technology, advancements, and innovations. Advancements in solar observation technology have revolutionized our understanding of the Sun. From ground-based telescopes to space missions like the Parker Solar Probe, these technologies have allowed us to study the Sun in unprecedented detail. Innovations in imaging, spectroscopy, and remote sensing are crucial for furthering our knowledge of solar physics and its effects on the solar system. The Sun's impact on human technology. The Sun's influence extends to human technology, affecting everything from satellite operations to power grid stability. Solar flares and coronal mass ejections can disrupt telecommunications and GPS signals. Understanding and predicting solar activity is therefore vital for protecting and optimizing our technological infrastructure in space and on Earth. The Sun's role in the solar system's formation. The Sun was instrumental in shaping the solar system as we know it. Its formation triggered the accretion of planets, moons, and other celestial bodies from the surrounding protoplanetary disk. Studying the Sun's formation and early history provides critical insights into the origins and evolution of our solar system, helping us understand the processes that led to the creation of Earth and other planets. Exploring the Sun's magnetic field, a cosmic force. The Sun's magnetic field, extending far beyond the star itself, is a powerful cosmic force. It influences solar phenomena like sunspots, solar flares, and coronal mass ejections, and shapes the heliospheric environment. Understanding the Sun's magnetic field is crucial for comprehending solar activity cycles and their impacts on the solar system in interstellar space. The Sun's influence on life on Earth. The Sun is fundamental to life on Earth, driving photosynthesis, weather patterns, and climate systems. Its consistent energy output has allowed life to flourish and evolve. Understanding the Sun's influence on Earth's biosphere is vital for appreciating the delicate balance of conditions that sustain life and for predicting how changes in solar activity might affect Earth's ecosystems. The Sun as a cosmic laboratory. The Sun serves as a natural laboratory for studying fundamental physics, from nuclear fusion to plasma dynamics. Observations and studies of the Sun provide insights into physical processes that are difficult or impossible to replicate on Earth. This research enhances our understanding of the laws of physics and contributes to advancements in various scientific fields. The Sun's spectral signatures, decoding stellar secrets. Through spectral analysis, scientists can decode the Sun's composition, temperature, and motion. Each element in the Sun's atmosphere leaves a unique spectral fingerprint, allowing astronomers to study the star's properties and behavior in detail. This information is essential for understanding not only the Sun, but also other stars in the universe. The Sun's atmospheric layers, a complex structure. The Sun's atmosphere is composed of several layers, each with unique characteristics. The photosphere, chromosphere, and corona are stacked in this order, with each layer playing a distinct role in solar phenomena. From the visible light of the photosphere to the highly energetic emissions of the corona, these layers are key to understanding the Sun's electromagnetic, thermal, and dynamic properties. Solar probes touching the Sun's edge. Solar probes, such as NASA's Parker Solar Probe, are pushing the boundaries of human exploration by venturing closer to the Sun than any spacecraft before. These missions provide invaluable data on the Sun's environment, including its magnetic fields, plasma waves, and solar wind dynamics. This information is crucial for improving our understanding of stellar physics and protecting Earth-based technologies from solar radiation. The Sun's variable output effects on the Earth. The Sun's output is not constant, but varies over time, impacting Earth in various ways. These variations can affect Earth's climate, satellite operations, and even the conditions for astronauts in space. Studying these fluctuations helps us prepare for and mitigate their effects on our planet and technological systems. The Sun in ancient cultures, symbolism, and reverence. Throughout history, the Sun has been revered and symbolized in various cultures. Ancient civilizations built monuments aligned with the Sun and based calendars on its movements. These cultural perspectives offer a window into how our ancestors viewed and understood this central celestial body, blending mythology with early astronomical observations. Future solar research, challenges, and opportunities. Future research into the Sun poses both challenges and opportunities. Advancements in technology promise more detailed observations and a better understanding of solar phenomena. However, studying a star as dynamic and complex as the Sun requires innovative approaches and international collaboration. The future of solar research holds the potential for groundbreaking discoveries in astrophysics and solar-terrestrial relations. The Sun's life-giving energy, photosynthesis, and ecosystems. The Sun's energy is fundamental to photosynthesis, the process by which plants convert light into chemical energy. This process is the cornerstone of Earth's ecosystems, supporting a diverse range of life forms. By understanding the Sun's role in photosynthesis, we gain insights into ecological networks and the balance of life on our planet. Studying the Sun's seismic waves. Helioseismology. Helioseismology, the study of seismic waves within the Sun, provides a unique method to probe its internal structure. These waves, caused by turbulent motions in the Sun's interior, offer clues about its composition, rotation, and hidden dynamics. Helioseismology is a key tool for astronomers to understand the Sun's inner workings without direct observation. The Sun's fluctuating magnetic field, solar maxima and minima. The Sun undergoes periods of heightened and reduced magnetic activity known as solar maxima and minima. These cycles have significant implications for solar phenomena like sunspots and solar flares. Understanding these cycles is essential for predicting solar activity and its potential impacts on Earth's space environment and climate. The Sun's impact on human health and well-being. The Sun's light and warmth have profound effects on human health and well-being. Sunlight regulates our circadian rhythms, influences mood, and is crucial for vitamin D synthesis. However, exposure to solar ultraviolet radiation also poses health risks. Balancing these benefits and risks is important for optimizing our relationship with the sun. The sun as a benchmark in astrophysics. The sun is the most studied star and serves as a benchmark in astrophysics. By understanding the sun, astronomers can better interpret observations of other stars and stellar systems. The sun's proximity and detailed observability make it an essential reference for testing theories and models in stellar physics. The sun's outermost corona, understanding solar atmosphere. The sun's corona, its outermost atmospheric layer, presents a mystery. It is significantly hotter than the layers beneath. This enigmatic region, visible during solar eclipses, is a focus for solar physicists. Studying the corona is crucial for understanding solar wind formation and the mechanisms behind coronal heating, which remains some of the most intriguing puzzles in solar science. Solar flares and spaced weather prediction. Solar flares, intense bursts of radiation from the sun, can have far-reaching effects on Earth, from disrupting communications to affecting power grids. The ability to predict these flares is essential for mitigating their impact on our increasingly technology-reliant world. Advances in space weather forecasting are improving our preparedness for these solar events. The sun and climate change. Solar influence on Earth's climate. The sun plays a complex role in Earth's climate system. While solar variations are minor compared to human-induced climate change, understanding the sun's influence on climate is vital for accurate climate modeling and predictions. Research into solar irradiance and its historical fluctuations helps clarify the sun's role in climate dynamics. The sun in literature and art, a source of inspiration. The sun has been a source of inspiration in literature and art throughout human history. Its symbolism and imagery have been used to convey themes of life, renewal, and energy. Exploring the sun's portrayal in cultural works provides insights into our changing perceptions and emotional connections with this celestial body. Renewable energy, harnessing the sun's power. The sun is a key source of renewable energy, most notably through solar power. Harnessing the sun's energy through photovoltaic cells and other technologies is crucial for sustainable development and reducing carbon emissions. The growing field of solar energy research and development is vital for creating a cleaner, more sustainable future. The sun and solar eclipses, unveiling hidden secrets. Solar eclipses, when the moon temporarily obscures the sun, offer unique opportunities for scientific study. These events allow astronomers to observe the sun's corona and chromosphere in detail, revealing insights about solar wind and magnetic fields. Solar eclipses have historically been pivotal in advancing our understanding of solar physics and have contributed significantly to the field of astrophysics. The sun's role in space exploration. The sun plays a critical role in space exploration. Its gravitational force is used in trajectory planning for spacecraft, and solar energy powers many space missions. Understanding solar radiation is also vital for protecting astronauts and equipment in space. The sun's influence extends beyond Earth, shaping the conditions for exploration throughout the solar system. The sun's ancient observatories. Archaeoastronomy insights. Ancient cultures built observatories and monuments aligned with the sun to mark seasons and significant celestial events. These structures, studied under archaeoastronomy, provide insights into early human understanding of the sun and its movements. Investigating these sites helps unravel how ancient civilizations observed and revered the sun and modern technology, solar innovations. Modern technology continues to evolve with the sun as a central focus. Innovations in solar energy, space weather forecasting, and materials science are driven by our need to understand and harness the sun's power. These advancements have far-reaching implications, from improving energy sustainability to protecting Earth's technological infrastructure. The Sun, a gateway to the universe. The Sun is not just our nearest star, it's a gateway to understanding the universe. By studying the Sun, we gain insights into stellar processes that apply to other stars and galactic phenomena. The Sun serves as a model for understanding stellar life cycles, nuclear fusion, and the balance of forces in a star, providing a foundation for broader astronomical studies. The Sun's interaction with other stars. While the Sun is the dominant star in our solar system, it is also part of a larger stellar community. Its interactions with nearby stars, though subtle and distant, play a role in the dynamics of the local interstellar neighborhood. Studying these interactions helps us understand the Sun's place in the Milky Way and its movement through the galaxy. The Sun's impact on planetary geology. The Sun influences the geological processes of planets in our solar system. Solar radiation drives atmospheric dynamics and weather patterns, which in turn affect geological features like erosion and sedimentation. Understanding the Sun's impact on planetary geology is crucial for interpreting the surface features of planets and moons. The Sun's role in the water cycle. The Sun is central to Earth's water cycle. Its energy drives evaporation, which forms clouds and eventually leads to precipitation. This cycle is crucial for maintaining Earth's ecosystems and human life. Understanding the Sun's role in this cycle is vital for managing water resources and predicting changes in climate patterns. The psychological effects of sunlight. Sunlight has significant psychological effects on humans. Exposure to natural light is known to improve mood, enhance sleep quality, and boost overall well-being. Understanding the psychological impact of sunlight is important for urban planning, workplace design, and addressing seasonal affective disorder. The Sun's ultraviolet radiation, balancing benefits and risks. The Sun's ultraviolet, UV radiation, is a double-edged sword. While it is essential for vitamin D synthesis in humans, excessive exposure can lead to skin damage and increase the risk of skin cancer. Understanding the balance of UV radiation's benefits and risks is important for public health recommendations and individual health choices. The Sun's effect on satellite technology. The Sun's influence extends to our orbiting technology. Solar radiation can impact satellite operations, affecting communication, navigation, and scientific data collection. Solar flares and coronal mass ejections can disrupt satellite electronics and communications. Understanding these effects is crucial for designing more resilient space technologies and ensuring reliable satellite services. The Sun and the origins of the solar wind. The solar wind, a stream of charged particles flowing out from the Sun, plays a critical role in shaping the heliosphere and interacting with planetary magnetospheres. Understanding the origins and behavior of the solar wind is key to comprehending the Sun's influence on the solar system and protecting Earth from space weather effects. The Sun's role in astronomical phenomena. The Sun is a key player in various astronomical phenomena, such as the creation of comets' tails and the ionization of planetary atmospheres. Its interactions with other celestial bodies reveal much about the nature of our solar system and the forces that govern it. Studying these phenomena offers insights into the broader workings of the cosmos. The future of solar power, innovations, and potential. The potential of solar power as a renewable energy source is immense. Innovations in solar panel technology and energy storage are making solar power more efficient and accessible. Exploring the future of solar energy helps us understand its role in transitioning to a more sustainable and cleaner energy future. The Sun in mythology and religion, a universal symbol. Throughout history, the Sun has been a powerful symbol in mythology and religion, representing life, power, and renewal. Its presence in various cultural narratives and rituals underscores its universal importance to human societies. Exploring these mythological and religious contexts enriches our understanding of the Sun's cultural and symbolic significance. The Sun and environmental systems on Earth. The sun is a fundamental driver of Earth's environmental systems. Its energy influences global weather patterns, ocean currents, and climate systems. The study of the sun's interaction with Earth's environment is critical for understanding natural cycles, predicting weather patterns, and addressing the challenges of climate change. The sun's magnetic cycle, a deeper look. The sun's magnetic cycle, spanning approximately 11 years, involves the periodic change in its magnetic field. This cycle influences solar activity, including the frequency of sunspots and solar flares. Understanding this cycle is essential for predicting solar behavior and its impact on space weather and terrestrial systems. The impact of the sun on agricultural practices. The sun's cycles and behavior directly affect agricultural practices. Understanding solar radiation patterns is crucial for crop planting, irrigation management, and pest control. The sun's influence on climate and weather patterns also plays a significant role in agricultural productivity and sustainability. Solar phenomena, eclipses, transits, and occultations. Solar phenomena such as eclipses, transits, and occultations offer unique opportunities for scientific study and public engagement with astronomy. These events not only provide insights into the sun's properties, but also serve as tools for measuring distances in our solar system and understanding celestial mechanics. The sun and human history. Influences on civilization. The sun has profoundly influenced human history, from the development of calendars to its role in agriculture and navigation. Civilizations have aligned their structures with the sun's movements and based significant cultural practices around solar events. The study of these historical interactions enriches our understanding of the sun's impact on the development of human societies. The sun and space-time gravitational effects. The sun, as the largest mass in our solar system, exerts significant gravitational effects, influencing the orbits of planets, comets, and asteroids. This gravitational force is key to maintaining the structure of the solar system. Understanding these effects is crucial for space navigation and studying the dynamics of celestial bodies. The sun's light, spectral analysis, and astrophysical insights. The spectrum of the sun's light provides a wealth of astrophysical information. By analyzing this spectrum, scientists can determine the sun's chemical composition, temperature, and motion. This analysis is critical for understanding not just the sun, but also the properties of other stars and the nature of the universe. The sun in education, teaching astronomy and science. The sun is a fundamental subject in the teaching of astronomy and science. Its observable nature makes it an excellent tool for introducing concepts of astrophysics, energy, and the natural world. Educational initiatives focused on the sun help inspire the next generation of scientists and astronomers. The sun's role in the galactic ecosystem. The sun's position and motion in the Milky Way galaxy are important for understanding our place in the universe. Its interactions within the galactic ecosystem, such as with interstellar clouds and cosmic radiation, provide insights into the dynamics of galaxies and the life cycle of stars. The sun and renewable energy technologies. Advancements in renewable energy technologies, particularly solar power, are closely linked to our understanding of the sun. Improvements in solar panel efficiency, energy storage solutions, and the integration of solar energy into power grids are essential for a sustainable energy future. The sun's role in renewable energy represents a critical area of research and development. The sun and exoplanet research. The study of the sun provides valuable insights into exoplanet research. By understanding our own star, scientists can better interpret the data from distant stars and their orbiting planets. This knowledge aids in identifying exoplanets that may have Earth-like conditions and in understanding the diversity of planetary systems in the universe. The sun's sound, studying solar acoustics. Solar acoustics, the study of sound waves within the sun, offers a unique perspective on its internal dynamics. These sound waves, a observed as oscillations on the sun's surface, provide information about its internal structure and energy transfer processes. Solar acoustics is a growing field, revealing hidden aspects of solar physics, the sun and human culture, celebrations, and traditions. The sun has been central to many human celebrations and traditions throughout history. From solstices to sun dances, various cultures have honored the sun's cycles and influence on the earth. These traditions highlight the sun's integral role in shaping cultural identities and worldviews. The sun as an energy source in space exploration. The sun is a vital energy source for space exploration. Solar-powered spacecraft and satellites rely on the sun for energy, enabling long-duration missions and exploration of the solar system. Research into more efficient solar energy utilization in space continues to advance our capabilities in space exploration. The sun and climate science, solar variability, and Earth's climate. The sun's variability, including changes in solar irradiance, plays a role in Earth's climate science. While not the primary driver of current climate change, understanding solar variability is important for comprehensive climate modeling and understanding natural climate variations on Earth over time. The sun's role in cosmic ray generation. The sun plays a role in the generation and modulation of cosmic rays, energetic particles originating from outer space. Solar winds and the sun's magnetic field can influence the intensity and composition of cosmic rays that reach Earth. Understanding this interaction is crucial for studying particle physics and protecting astronauts in space from radiation exposure. Sunlight and its effect on architectural design. Sunlight has a significant impact on architectural design. Architects consider the sun's position and movement for natural lighting, heating, and cooling. This solar consideration leads to energy-efficient, sustainable building designs and improved indoor environments. The study of sunlight in architecture underscores its importance in environmental design. The sun in literature and popular media. The sun has been a prevalent theme in literature and popular media, symbolizing hope, renewal, and the passage of time. Its representation in various literary and media forms reflects our evolving relationship with and understanding of this celestial body. The sun's portrayal in these contexts offers insights into human creativity and expression. The sun and its role in natural disasters. Solar activity can indirectly influence natural disasters on Earth. For instance, intense solar flares can affect Earth's upper atmosphere, potentially impacting satellite operations and communications, which are crucial in disaster prediction and management. Understanding the sun's role in these processes is important for disaster preparedness and response. The sun and future space missions. The sun will continue to be a focal point for future space missions. Projects like solar probes, solar observatories, and missions to study the Sun-Earth connection are vital for advancing our understanding of solar physics and its effects on the solar system. These missions promise to uncover new knowledge about our star and its dynamic behavior. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions, updates, and awe-inspiring visualizations of the universe. Live Q and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.